Okay, so find the most general antiderivative of the function. This technically is both section 4.9 and section 5.4, right? The way they ask for it in section 5.4 is they put the integral symbol without numbers on the ends, right? So what's the antiderivative of 1 over x? Natural log absolute value x. How about 1 over x squared plus 1? Arctangent, great. And then the most general portion of that means you do have to have plus c. Because you don't know if your c is 1, 2, 7, pi, e, whatever, 0. You just don't know. Do you need plus c when it's a definite integral? No. Okay. So how about this one? Is there a quotient rule for anti-differentiation?
No.
No, don't make one up. It'll be wrong. So simplify this first. I think that the thing that you guys come up with first is writing this like this, as in times x to the negative 1. Yes? There's still no product rule either, so don't make one of those up either. Then distribute, and what happens to your exponents? They add. So you get x plus x to the negative 1/2. And that's still f, so I can still say equals. It's not the antiderivative yet. For this section, the way you say antiderivative is you say, okay, capital F. And that's just the way they do it. What's the antiderivative of x? Great. What's the antiderivative of x to the negative 1/2? Gesundheit. 2x to the half, and then plus c. I can't make you write that as root x without asking for it explicitly, but you know, it is kind of better to at least know that x to the 1/2 is root x, but you know, really, unless I legislate it, I don't think I can take off points for having an equivalent, also correct answer. So. Okay, is that all right? Something else we talked about in this section was if you are given information about a derivative or a second derivative and some initial conditions, how can you find the original function? Okay? Yep, to plug those things in though, you have to first figure out what the function f is, don't you? Okay, so we know that the second derivative is 5x cubed plus 6x squared plus 2. So given that, go one derivative back by anti-differentiating once. What do we get? 5/4 x to the 4th, okay. Plus 2x to the 3rd. Plus c. Yes?
The f of 0 is that equals to, is that supposed to be f prime?
It's actually not. You could have been given f prime of 0 was 3, and then you could find the c right now. But this actually does mean f. And you can actually do that. It does work. So go back once more. So f of x will be, I think this will be 1/4 x to the 5th. Do you guys agree with that? Because I'll have a 1/5 that came up, which will cancel the 5. Plus 1/2 x to the 4th. And then what's the antiderivative of c? Cx. And then you just add another letter, d. You could, sometimes people call them c sub 1 and c sub 2. Like, you know, the first c, second c, but you know.
Was there any point in finding f of x before you figure out what c is?
Is there any? There's no other way to do it. As in, you don't have any information that would tell you what c is.
Because you only have f.
Because you only have information about f. So in order to figure out what c is at the step before going back from f prime to f, you would have to know something about f prime. Does that make sense? I mean, so I can't find c with this information I've been given. Because they're both about f.
Well, can't you find a slope?
You don't, but then you'd have to be given information about the derivative. So you can't.
All right.
Well, you're thinking, can you find a slope with those 2 points? Is that what you're thinking?
Yeah.
That won't find the derivative, it'll find the slope with the secant line, which might not be the same thing.
All right.
Does that make sense? So yeah, no, it's a reasonable idea, but it won't work. Now you use this information to get the c and the d. So I think it's probably easiest to plug in 0, right? So we're going to get 3 equals 0 plus 0 plus 0. What's c times 0? 0. And then plus d. So that implies d equals 3, right? So now you know this much about f. F of x is a quarter x to the 5th plus a half x to the 4th plus x squared plus cx plus 3. And next, you know, when you plug in 1 for x, what does the y come out to be? So that'd be negative 2 equals a quarter plus a half plus 1 plus c plus 3. So negative 2 equals, I think, 4 plus 3/4. Do you guys agree with that? So negative 2 equals 17 quarters. Is that right? Multiplying 4 by 4 over 4. Oh, that's not right. What should it be? 19 quarters, right? Does that seem more right? Yeah, okay. So then take away 19 quarters. So negative 8/4 minus 19/4 will equal c. C is minus 27/4. So your function f of x is 1/4 x to the 5th plus a half x to the 4th plus x squared minus 27/4 x plus 3. Is that all right? Other than arithmetic being the bane of your existence, bane of mine. All right. The next one effectively tests the same thing, but it also tests your ability to know the relationship between velocity and acceleration and stuff like that. So a particle is moving with velocity 2t minus 1 over t squared, and s of 0 equals 1, which means at time equals 0, the position is 1. This should say find, obviously, you know. Find, not flipper the position, find the position. So find the position of the particle. So how do you go from velocity back to position?
Take this integral.
Take this integral or find the antiderivative. With symbols you now know, you could say that s of t is equal to the antiderivative of v of t, right? Plus a constant c, because that will up to that much. So what's the antiderivative of 2t? Your t squared. What's the antiderivative of the 1 over 1 plus t squared? Arc tangent t, yep. Plus your constant c. And unlike the previous one, you only gotta go back 1 this time, right? Okay. So now you can plug in your information. So what goes in for s of t? 1, right? And what goes in for t? 0. So 1 equals 0 squared minus arc tangent 0 plus c. And what is arctan of 0? 0. So I think 1 equals c, right? So s of t is t squared minus arctan t plus 1.
I got confused the way you wrote that. I thought it was 2t minus 1 all over 1 plus t squared.
Yeah, that's what I thought.
Oh, well, you know, that's PEMDAS for you. If it was that, I would have to have written it like this. If I meant that those things were in the numerator, you have to put parentheses around them. That's an order of operations thing. Like if you think of order of operations, you know, the parentheses, exponents, multiplications, divisions, additions, subtractions. comparing these operations, this has to occur before doing the 2t minus. It's actually something I've had a thing I made my calculus students read back when I taught high school that was sloppy notation mistakes that can make your answer actually wrong. If your intention is to write 2t minus 1 over 1 plus t squared, you have to do parentheses if you're going to write it horizontally to signify the whole thing is in the numerator. Otherwise, it's not. So, I mean, the other way to think about it is this division happens before that subtraction, right? That's why it has to be this. Yeah. Okay. So that really was section 4.9 / section 5.4. Kind of both at the same time. So the big ideas in this class is that a derivative tells you the rate of change of a function of a slope of the tangent line, which is the rate of change. And an integral, a definite integral, tells you the area under a curve. That's like the big idea behind antidifferentiation and integrals. And all these ideas come from the idea that you can take a curve and estimate the area underneath it using something like rectangles. So this is section 5.1, where you're estimating areas under curves using left endpoints, right endpoints, etc. So if you have the curve x squared plus 2, that's a parabola shifted up 2, right? So it looks approximately like, I mean, that's a bad parabola, but you know, it's U-shaped and it's above the x-axis, right? So if I want you to estimate the area under the curve from 0 to 8 using 4 subintervals and using left endpoints. So first of all, how wide is each interval, which we call delta x? 2, yep. 8 minus 0 over 4, or 2. 2, 4, 6, 8. If you do left endpoints, the picture will look like this. You take each subinterval and you plug in the number on the left. So first you plug in 0. What do you plug in next? Find the height at 2, then who? 4, and lastly 6. And those are all rectangles, and because you all passed the 3rd grade, you can find areas of rectangles. Yes? Don't let me down now. One would hope, one would hope, and one would hope one is not disappointed. What is the base of every single rectangle? 2. How do you find the height of rectangle number 1? It's 2. You got that by plugging 0 in. Does that make sense? So if I say y of 0, and then I just do a second step that says that that's 2, is that okay? Just to be clear, that's what I did. I plugged in 0. What do you plug in next? Get your next height. 2. And what do you get when you do that? 6. Great. What do you plug in next? And I think that's 18. But arithmetic, not my thing. 16 plus 2, yes? Okay. What's the last thing you plug in? 6, which is 38. Okay, so that adds to 40, 58, 64. Yes? Okay. 40, 18, 6. Yeah, there we go. Okay, 64. And then 2 times 64 is 128. And from the picture, is it totally obvious that that's an underestimate? Yeah. Underestimate. Because the boxes, so the actual area under the curve.
The box, never.
Yeah.
Forget my question.
Okay, yeah, the boxes are under the curve. If your function is increasing, your left estimate will be an underestimate. Let's just write down what R6 would be. So R6 would be 2 times, what would be the first thing you'd plug in instead of 0? You'd plug in 2 first, right? Oh, yes, it'd be R4. Yes, thank you. Yes, it'd be R4 because of 4 pieces. So first you'd plug in 2. What would you plug in next? Y of 4, yep. Then you'd plug in, yep. And then you'd plug in, yep. And you'd get some larger number, right? Okay. So whatever, you can, I'm sure you, if you can, the other thing is on your test, it'd be really great if you could like write down an expression like this so I know that your only mistake isn't arithmetic. Does that make sense? Or at least if you show me what you're adding, I can see if like you just missed one number or all of them. Does that make sense? Okay. What about midpoints? So take that same picture. We have our parabola up to 8, 4, 2, 6. So when you do left endpoints, you plug in the number on the left. When you do right endpoints, you plug in the number on the right. What are we going to do with midpoints? Plug in the number in the middle. So the first middle number is 1. The second middle number is 3. The next middle number is 5. And the last middle number is 7. And the width of every single box is still 2, right? So that'd be 2 times y of 1 plus y of 3 plus y of 5 plus y of 7. Does that make sense? So 2 times 3 plus 11 plus 27 and plus, I think, 51. Does that make sense? Somehow I just can't add horizontally. 51, 27, 11, 3, 10, 12, 5, 6, 7, 8, 92? Does that make sense? Is that not right? For the middle, 2 times 92. And then 184, is that better? Okay. And I guess the clever thing is those two add to 30, these two add to 62, and therefore 92, right? Whew. Okay. You can't, and I wouldn't have asked, because it isn't obvious. If I'm going to ask you that question, it's going to be totally obvious. But if the function isn't obviously increasing or decreasing, you really don't know. I don't know, because what matters is more of this box out than in, and my picture isn't good enough for me to tell. I suspect that maybe it's an overestimate, but it's not clear.
The other one's easy because you have
The other one is, yeah, I would only ask you if it was obvious.
If you did a right side on that,
Mm-hmm.
will they all be over?
Yeah, for the right side, they all be over. Okay, so find the following definite integrals. So, oh man. So what I did with this is I mixed in section 5.5 where you have to use substitution. Substitution is the trickiest technique you have, and you've got to know when you have to use it. If your thing you want to anti-differentiate something more complicated than, oh, I just know what that is, substitution is your method. Does that make sense? So is there something you could substitute to make this thing, like if something's derivatives show up?
Tangent?
Tangents. So would it be easiest to substitute for a tangent, or can you do the whole denominator?
Whole thing.
If you can do the whole thing, do it. If you let u equal tan t plus 1,
Didn't you put square root of secant squared?
wouldn't I put the square root of secant?
Because tan
Oh, you're thinking square roots distribute when they don't. So tan squared plus 1 equals secant squared. Like, that's true. But if you square root this side, that root can't say, it can't become tan x plus 1, because roots don't distribute. So yeah, only, yep, nope, doesn't work. Okay, so if your u is tan t plus 1, what's the derivative of that? And you're gonna know this method will work when that derivative shows up in your integral. And you're like, woohoo, I got it, yeah. Now with definite integrals, you also need to change your bounds. So if t is equal to 0, u equals tangent of 0 plus 1, which is 1, right? And if t is pi quarters, u is equal to tangent of pi quarters plus 1, which is 2. Yep, so this becomes the integral from 1 to 2. I believe it's just 1 over u du now. And if you were to graph both of those functions, the area under the first more complicated curve between 0 and pi quarters is the same as the area under the second less complicated curve between 1 and 2. So just find that one. Don't find the first one. So what's the antiderivative of 1 over u? So that's ln of 2 minus ln of 1, which is ln of 2. Someone asked a question, I couldn't quite hear what it was. Was you making it?
I got it wrong.
Okay. What did you do incorrectly?
I put it 1 over, negative 1 over u squared.
You took the derivative.
Yeah.
Does that make sense?
Yeah.
Yep. But does the fact that it's not that make sense as well? Okay, alrighty. Is substitution the method for part B? Do you have to substitute? Can you find the, so we found an antiderivative of something like that earlier today, didn't we? So first, write this as, first select your pencil tool, then write it as x minus 2 times x to the negative 1/2. I think that would be your guys' first instinct, right? You tend to sort of favor that. There's no product rule. There's still no product rule. Don't try to make a product rule, okay? Still not happening. Distribute and do what to the exponents? Add 'em. X to the 1/2 minus 2x to the negative 1/2. Now, can you anti-differentiate?
Yes.
Yes. What's the antiderivative of x to the 1/2? 2/3 x to the 3/2. Minus, I think that's going to be 4x to the 1/2. Does that seem right? Because the antiderivative of x to the negative 1/2 will be x to the positive 1/2 times 2, right? Okay, evaluated from 1 to 4. So we got 2/3 times 4 to the 3/2 minus 4 root 4 minus 2/3 times 1 to the 3/2 minus 4 square root 1. Oh, so what's 4 to the 3/2? I think it's 8. So then it becomes 16/3 minus 8, right? And minus 2/3 plus 4, because 1 to the 3/2 is just 1, and square root of 1 is just 1, yes? Oh, arithmetic. So was that 14/3 minus 4, 14/3 minus 12/3, I think is 2/3. Do you agree? All right, is that right? The 8, so added,
14 thirds is 16 thirds minus 2 thirds, and the 12, or 12 thirds is the 4, but what about the 8?
because I have this 8 and this 4. And they added to -4. Okay. So how does this, yes?
Where'd the 8 go? I'm missing something.
All right. So how is this different than the previous one? Because there are no bounds, what do you have to have on the end?
So we gotta find the anti-derivatives.
Yeah, but they're really, they're in, that's like, feng shui. So that means you're gonna have plus c. Does that make sense? So what's the antiderivative of secant tan? Secant. How about this 2 over the root of 1 minus x squared?
2 arc sine.
2 arc sine. Plus c. That's it. So some of these things you just have to know. The derivative of arc sine is 1 over root of stuff, and the 2 out in front doesn't actually matter, right? Okay. Other things you may have to do substitution. Like part B. Does that make sense? Probably going to have to substitute. What you're going to let be your u, probably.
X minus 2.
Probably the x minus 2, because what else is there, right? Then what's du? Just 1 dx, right? So what could you replace the x in the numerator by? Yep, u plus 2 will equal x. That is the trickiest substitution is going to get. Like, other than not knowing what to choose, which is also tricky in and of itself. So you get u plus 2 over u to the 3rd, I believe, right? And then where do you go from there?
Simplify it.
So by which I think most of you would bring that u to the 3rd to the top, right? And then you'd add exponents. So you get u to the -2nd plus 2u to the -3rd. And then it's just a question of can you add negatives correctly? Which is not always a guarantee, no offense. What's the antiderivative of u to the -2? What do you do to the exponent when you antidifferentiate? You add one, right? When you differentiate, I love alliteration. When you differentiate, the exponent goes down. When you antidifferentiate, you add, it goes up, right? So negative, and the -2 plus 1 is -1, right? U to the -2, right? Over -2. So think, what's the pattern for x cubed? It's x to the 4th over 4, right? Same pattern for these, you just have to abstract it a little bit. Plus c. So it's -1 over u minus 1 over u squared plus c. Or -1 over x minus 2 minus 1 over x minus 2 squared. And there's no need to get common denominators with these guys. You don't have to, because technically the c can't ever be common denominator, like not easily or nicely. So it's pretty much never asked that you're never asked to do that. Is that okay? All right. All right, not an easy antiderivative, so probably substitution. What do you think you're going to let u equal?
1 over x.
1 over x, because really there's no other option. That's usually let u be the inside function. It's inside of something. So what's the derivative of 1 over x? Almost -1 over x squared. I think maybe you said that and I didn't hear you. Okay. So -1 over x squared. You don't have -1 over x squared. You have 1 over x squared. So move the negative over with the du. So this will be negative anti-integral sine of u. If you make the right substitution, the integral or the antiderivative should become really, really easy. So is the antiderivative sign regular cosine or is it negative cosine? It's negative. I need plus c, so the negatives cancel, giving you positive cosine plus c. And because this is not a definite integral, you have to insert what u is. So this is cosine of 1 over x. This rule kind of undoes the chain rule. The chain rule dealt with inside, outside functions and compositions, right? The thing you substitute is the thing inside. Okay. What are you going to let u equal here? Let u equal cosine inverse. It won't work to let u equal 1 minus x squared because the derivative of that is negative 2x. And then there's no whatever, no. So let u be cosine inverse. What's the derivative of cosine inverse? And that's the rest of it. That's pretty much the rest of it showing up, isn't it? So what we have now is negative integral of what? What is the cosine inverse replaced by? And the dx over the root of stuff is negative du, but yep. So what's the antiderivative of negative u? Negative 1/2 u squared plus c. So negative 1/2 cosine inverse x, the quantity squared, plus c. You could also say arc cosine, that'd be fine as well, same thing. Okay. Find the derivatives of these functions. So these are functions that find areas under curves to a variable point. So remember, if we had these functions, f of x equaled, say, integral, we'll say 1 to u not square root, we'll say, give it a name. Integral 1 to u little f of t dt. The derivative rule said that this guy's derivative was f of u times du dx. F of u is just the function that's inside the integral symbol with u plugged in instead of x, or instead of t. And think about that. F prime is the derivative of the antiderivative on these questions. The students always freak themselves out thinking that it must be more complicated than it actually is. It's not actually that complicated. So this is your f function. I've just differentiated both sides, right? I think it'd be helpful to write that step down. So then think about how you do this. First, you're going to take the antiderivative, and you're going to plug in x cubed, you're going to plug in 2, right? And then what are you going to do to that function? You're going to differentiate it. So if you take the antiderivative and then take the derivative, nothing is going to change. You go antiderivative of root, and that's not something you can anti-differentiate easily, is it? Okay, so you find the antiderivative of that at some mystery thing, okay? What happens when you take the derivative? Takes you back to where you were, right? Now, the one funky thing is that antiderivative, the mystery thing, you've plugged in x cubed and you've plugged in 2, right? if you differentiate plugging in 2, that's just a number, its derivative is 0, right? When you differentiate plugging in x cubed, you've got to multiply by the derivative, which is 3x squared, because you've input something that's not just x. So this derivative is just that function with x to the third plugged in times 3x squared. Let me just show you with an easy function where we can actually do it. So if I gave you f of x was the integral from 2 to x cubed, let's say secant squared of t dt. Okay, just because that one you can actually anti-differentiate and you can see the pattern. But the thing is you have to know the pattern so you can use it without having to actually rely on this, okay? So the question said take the derivatives. There you go. F prime is the derivative of this weird thing. Okay, so first you do this part. What's the antiderivative of secant squared t? Tangent t. And you plug in 2 and you plug in x cubed, right? Okay. And then the antiderivative, and so then you plug in x cubed, and you still haven't taken the derivative, have you? So that d over dx stays. You got tangent of x cubed minus tangent of 2, right? What's the derivative of tangent of x cubed? What rule must you use to differentiate that? The chains. What's the derivative of the tangent? Would be secant squared of x cubed, right? Multiplied by what from the chain rule? 3x squared. And the tangent 2's derivative is just 0, right? So look at how this relates to the original thing, right? All that happened is x cubed got plugged in for t, and you multiplied by x cubed's derivative. Okay, that is the pattern. It's just that I'll give you a function for which you can't actually do the antiderivative on it. Like, it's just not possible for you to figure it out. You've got to know that's the pattern. But that's why. Okay. This did rely on that second one being a number. Does that make sense? It's like this one that we have, they're not both numbers, right? The bounds. So the trick with that one, I think there is a way to make this work a different way, but I would always do it this way. I integrate from e to the x to some middle point 0 plus 0 to x cubed, x squared, sorry. I think that there is another way to make this work. I'm just reticent to tell you that I'm not sure, but I'm pretty sure that there is. We can discuss it at the end once I'm positive, okay? So this is the same thing as negative 0 to e to the x. Yeah, because the rule we had also does rely on you having number to variable, so. Yeah. First step, break it up. Second step, flip it. And you could totally do that in one step if you're like, if you're chill with that. Okay, so that's still the original function, okay? So now h prime is the derivative of those two components. Okay. So what's the derivative of the first component? What do you do? Secant of e to the x times e to the x, and that can't multiply by the e to the x and the secant, plus secant of x squared times 2x, yep. Or rewritten 2x secant of x squared minus e to the x secant of e to the x. So I think what I was thinking was actually correct. So look at this guy. Is there a pattern between that and the answer that's sort of semi-obvious? You have the secant function with x squared plugged in first, right? Minus the secant function with e to the x plugged in second, and then multiplied by the derivatives of the x squared and the e to the x on each of their respective terms. That will always work. Because you're always doing the same thing. You're always breaking into two, flipping one of them, right? It's always happening, so. Okay. Woo! Okay, the difference between displacement and distance traveled. So with displacement, you're still accounting for negative area, as in you're saying, how much has my position changed? And if the particle goes backwards and forwards, maybe you change nothing, right? So we want to find the displacement over the time interval from 0 to 3. That is just the definite integral from 0 to 3 of t squared minus 2t. That's not very hard to do, is it? No. So that's going to be 1/3 t cubed minus t squared from 0 to 3, or 27/3 minus 9, which holy moly happens to be 0. So 0 meters. Does this mean your particle didn't move? No. I mean, it could have not moved, right? It's possible, but it probably means it went both forwards and then backwards. Okay. So how do you find the distance trapped? To do distance, you do the integral of the absolute value. Because what that's going to do is going to take all the negative areas and make them positive areas. Okay? And the way to evaluate that integral is to look at your picture and figure out where is that thing negative. So look at the v of t function. So v of t is t squared minus 2t, which is the same thing as t times t minus 2. So if I was graphing this parabola, where would it cross the t or x-axis? 2, and where else? 0. And it'll look like this, right? So if you're going to break that absolute value up, the first part is from 0 to 2, right? And that's the part that in the original function is negative, right? So to flip it above the t-axis, you have to negate it, which will make it positive, right? And then plus the integral from 2 to 3 of t squared minus 2t. So that's negative 1/3 t cubed plus t squared from 0 to 2. Remember that? Is that okay? It's distributed the negative and the integer at the same time. And then plus 1/3 t cubed minus t squared from 2 to 3. So that's negative 8/3 plus 4 minus 0, that's the first integral, plus 27/3 minus 9 minus 8/3 minus 4. So how many thirds do I have? I was looking for a specific number.
27.
Is that your answer? I think it's negative 16 thirds.
Oh, I thought there was, yeah.
But I think that this ends up canceling, doesn't it? Because 27 thirds is 9, right?
Yeah, I thought it was like 8 thirds.
Okay. and then plus 8, do you agree? Because the negative distribution makes that 4 into positive. Okay. So 8 is 24 thirds. So negative 16 thirds plus 24 thirds is indeed 8 thirds. Ooh.
So,
Mm-hmm.
couldn't you try find the antiderivative to go to the position?
You could find the antiderivative to go to position. Could you? I don't think that you can because you don't know what the initial position is. So I think you could maybe make it work, but then you would have to do that whole number line chart like we did in the previous section. So I think it's possible. I don't think it's easier. Does that make sense? But I do. It is actually possible. You could assume the initial position was 0, figure out when it turned around, and then like count it out and add it up. Most of you weren't able to do that correctly. No offense, but I think this way is better. It also is how you integrate any absolute value. Like what if, for example, let's just do one little thing. We'll go to the next question in a second. What if I asked you to find the integral from 0 to, say, pi, absolute value of cosine of x? Okay, you're like, you're like, what the heck? So look at a graph of cosine. Where does cosine start? 1. Where does it cross? Pi over 2. And by pi, it's down at -1, right? So what does absolute valuing? I mean, if I were to graph the rest of it, there's the rest of it, right? What's absolute valuing going to do to all the bits that are below the x-axis? It's not going to get rid of them.
It's gonna move them.
It's going to flip them up. It's going to make them positive. So it becomes this little like thing, right? And so the way to find that area is then to do the integral from 0 to pi halves, and that's just regular cosine. That one was unchanged, right? And then plus the integral from pi halves to pi of negative cosine. That's the part that had to get flipped up, right? Because the way you flip it is you negate, right? Which you could technically do as twice the first integral because there is some symmetry and those two areas are definitely equal, right? Like this area is equal to that area, not in my picture, but in theoretically. In real life, yeah. So that's how you deal with any absolute values. You figure out which parts of the original graph are below the x-axis and they must be flipped up and you break it into many pieces. So it generalizes to more than just, displacement. Okay, cool. All right, a bacteria population is 4,000 at time t equals 0, and its rate of growth is this many bacteria per hour after t hours. What is the population after 1 hour? So if I find the antiderivative, I'll get the population of the bacteria plus some constant c, right? So if I take the antiderivative of 1,000 times 2 to the t, what's that? What is it?
1,000 times 2 to the t over natural log of 2.
Mm-hmm. Plus some constant c, right? Are you given any information? Let's call that, I don't know, p of t for population. Is 1,000 over ln 2 times 2 to the t plus c. Are you given any information that lets you figure out what c is? You're given this, right? So you know that when t is equal to 0, p of 0 is equal to 4,000, right? Does that make sense? So 4,000 will equal 1,000 over ln 2 times 2 to the 0 plus c, which means c is equal to 4,000 minus 1,000 over ln of 2. No one said it's pretty, but that's it, right? So here's your population equation. P of t is 1,000 over ln 2 times 2 to the t plus weirdness. Okay, so that's your population at any time. How could you figure out after uno hour? Plug in 1 for t, yep. So that will be 1,000 over ln of 2 times 2 plus 4,000 minus 1,000 over ln of 2. I don't have a calculator. I think I probably do. So could somebody calculator that for me, please? It's about equal to, round to the nearest. I'll double check. So if it was a test question, I would just like make you just be able to finish it. I got 5,442.7. Okay, approximately.
How'd you get it over two?
Oh, because the antiderivative of 2 to the t is 2 to the t over ln 2. So this is the hardest one for students to keep straight. The derivative of a to the x is what? Ln a times a to the x, yep. I know. The antiderivative of a to the x is 1 over ln a times a to the x. Let's see. So whatever you have to do to make yourself memorize that, or just remember that, it's, you know, I don't think tattoos are a great idea. They don't need anything that permanent. That's really not a good idea.
You know, I get derivatives.
Say that again?
And then antiderivatives on the side.
No henna tattoos. No.